Welcome to Quantum Mechanics. Today we'll learn how to calculate quantum numbers for carbon's 2p electrons in just a few minutes. Carbon has 6 electrons total, and we're going to focus specifically on determining the quantum numbers for its two 2p electrons. Understanding these quantum numbers will help you master electron configuration and chemical bonding concepts. First, let's establish carbon's complete electron configuration to identify where the 2p electrons are located. Carbon has atomic number 6, which means it has 6 electrons in its neutral state. Carbon's electron configuration is 1s squared 2s squared 2p squared, meaning 2 electrons in 1s, 2 electrons in 2s, and 2 electrons in 2p orbitals. We're specifically interested in those last 2 electrons that occupy the 2p orbitals. Every electron is described by 4 quantum numbers that act like a complete address system. The principal quantum number n tells us which energy level or shell the electron occupies. The angular momentum quantum number L describes the shape of the orbital where the electron is found. The magnetic quantum number ML specifies the exact orientation of that orbital in three-dimensional space. The spin quantum number MS describes the intrinsic spin direction of the electron itself. Now let's calculate the first 2 quantum numbers for carbon's 2p electrons. Since we're dealing with 2p electrons, the principal quantum number n equals 2, indicating the second energy level. For p orbitals, the angular momentum quantum number L always equals 1, which gives p orbitals their characteristic dumbbell shape. These values are the same for both 2p electrons in carbon, since they're both in 2p orbitals. Now for the magnetic and spin quantum numbers, which differ between the two 2p electrons. For L equals 1, the magnetic quantum number ML can be -1, 0, or +1, representing 3 different p orbital orientations. According to Hund's rule, electrons occupy orbitals singly before pairing up, so carbon's 2p electrons go in different orbitals. The first 2p electron has ML equals -1 and Ms equals +1/2. The second 2p electron has ML equals 0 and Ms equals +1/2. Here are the complete quantum number sets for both of carbon's 2p electrons. First 2p electron has the quantum numbers n equals 2, L equals 1, ML equals -1, and Ms equals +1/2. N equals 2, L equals 1, L equals -1, Ms equals +1/2. Second 2p electron has the quantum numbers n equals 2, L equals 1, ML equals 0, and Ms equals +1/2. N equals 2, L equals 1, ML equals 0, and Ms equals +1/2. Notice both electrons have parallel spins following Hund's rule for maximum stability. If this helped you understand quantum numbers for carbon's electrons, please like this video and subscribe to Zeppe Learn. Hit the like button if you now feel confident calculating quantum numbers for any atom's electrons. Subscribe for more chemistry tutorials, and don't forget to share this with your study group. Thanks for watching, and see you in the next chemistry lesson.